Will do. Will do. So, yeah. Okay, before I do anything, shortest distance area of the triangle. Okay, fine. Before I do anything, let me remind you one thing. Do you remember I introduced the cross product to you? Remember last time? Okay, so we'll start our journey from there. We'll start our journey from there. Okay, listen to me and revise yourself, right? So we understood that if this is A vector, if this is B vector, we understood that we are going to take these components and then we are going to take this component over here. Now, this guy is perpendicular to both of those vectors. That means that is in the third dimension. Okay, third dimension. From this paper, I'm not expecting that you are going to do wow. Okay, because I'm going to do these type of things every single month, and then you will do, I don't know, like 50 vector questions tests with me, and then again past papers with me. Then only you do wow, not now. Okay, so this is just to understand what to improve. So now let me say this is O, this is A, this point is B, this point is P. Yeah, those points are there. So now OA vector, what is given to you is OA vector is A. And OB vector is given to you as B. Okay, you pay attention. OB vector is B. Now, if vectors starting from the origin, we call them position vectors. Now, position vectors are starting from origin, 0, 0, 0 point, if you think about the three dimension, X, Y, Z. Now, OP distance is nothing but A vector dot B hat. You all good with that? So, this you can write A vector dot B hat is what? B hat is B vector divided by B vector dot B vector square root. So if you know this, you're up to the mark. So I will do this until you come to that mark. Student to student, the things are different because maybe last week one student have it in their pocket, this one. Others maybe not. That depends on your input, right? So understand. So if you have this, you are good. So now OP vector. What is OP vector? OP vector is, okay, OP vector is OP times direction. Direction is B hat. So OP is going to be A dot B hat, and then outside you have B hat. And outside you have B hat. So if you want, you can replace B hat by the other formulation, which is going to be B vector divided by B vector dot B vector square root. And then outside you have B vector divided by B vector dot B vector square root. All good? Right. Now, right. So now tell me, this is called scalar resolute. This guy is called vector resolute. Scalar resolute, vector resolute. We understood this 2 weeks ago. What about this guy? So that guy I'm going to say OQ, okay? So this point is Q, capital Q, OQ. Now OQ is what? OQ vector is what? OQ vector is perpendicular to other two. Your knowledge would be B vector cross with A vector. B vector cross with A vector. Make sense? All good? Okay. Okay. Tell me if there is any question, any problem here, because I don't want to in the next exam. I want all of you to perform. So any questions here? Whatever? No? All good? Yeah. Now, if you have any, I will do that because the initial piece we missed. We'll organize it today. So then if others need it, they can come to that session as well. Okay. So now look at this. I'm going to get this guy. Okay, look at this. Suppose this is theta, right? Suppose this is theta. So you understand this length is going to be, look at my board, A vector dot B hat. A vector dot B hat is A vector magnitude cosine theta. You understand that? You know that already, right? So that means that, what do you call it, base you have through the dot product, right? Now, what about this guy? So this is this guy. What about that vertical height? So you understand, we discussed that last time. The vertical height you can get B vector or maybe A vector cross with B hat. Yeah. B hat. And that magnitude that is given, that is that. So this is nothing but now A vector mod sine theta. So this guy, you know from Sokotova. This guy you know from Sokotova. When you have a right angle triangle, r cos theta, r sin theta. So r sin theta, r cos theta, now you wrote in terms of vectors. Why? If you really understood this one, okay, listen to me carefully now. This is a right angle triangle where the sides are given to you as lengths. So that means all of these sides are scalar values. Now, for the same triangle, we are going to give vector. So that means we are inducing that side to be a vector. So in math terms, we give directional sense to a value. Directional sense. Yeah. So previously, this is just a length. When you put this one, we are giving a directional sense to that length. That directional sense is given to you knowing the unit vector in that direction. We discussed that already, right? I'm just helping you to consolidate. Okay. So now when you have a vector, so this guy, okay, now let me do that. So this is a vector. This in this direction you have B hat. What I'm saying basically, this length you can write as A vector cross B hat. And this guy you can write A vector dot with B hat. That's what I'm saying. So a sine theta, a cos theta, what you have learned in grade 7, we are writing in vectors. Why? Because directional sensors are introduced. I don't know any other simple language to explain this. Does that make sense? Right. Okay. Okay. Now you tell me one thing. Now let's go to kindergarten. Suppose this is your triangle, right? So in your triangle, what is the area? Area is half times base times height, right? So half, fine. Base is what? Base is b cos theta, na? This one is a sin theta, right? So a cos theta, a sin theta, right? Now I can find the area of this dude half times a dot b hat multiplied with a cross b. Can I? Yeah. I can. I'm going to replace the things, right? So okay. So the knowledge we have is this. Knowledge we have is this. So when you have a vector here, and when the b hat is defined in this direction, what I'm saying now, this guy is going to be a cross b hat, and this guy is going to be a vector dot b hat. Then what I'm saying, area can be written as half times base is going to be a dot b hat, height is going to be a cross b hat. This is what I'm saying. So these are just notations, but look at the knowledge inside. Yeah. All good, ne? Yeah. So you guys are doing actually two subjects here because you can see like what type of math, what type of intellectual territory we are touching. So when you're touching this intellectual territory, math methods, it's just you are doing it. Some other people you might have seen, method is the big deal. Why? Because that's the maximum experience they have. For specialist students, method is not a big deal at all. But it happens eventually, not tomorrow. Right. So let me tell you the next part, which is important here, position vector concept. Position vector concept. So you understand the position vector is starting from the origin. Yes. So suppose I'm going to make three position vectors, okay? Like this, like this. This is O here. This is A. This is B. This is C. So what we say is A comma B comma C. A comma B comma C are position vectors. A comma B comma C are position vectors. A comma B comma C are position vectors. Okay. So suppose you need to find A B vector, right? Suppose you need to find AB vector. So AB vector, how do you write? You write A plus AB vector is equal to B vector. We call it vector addition. Vector addition. So how it works? A vector, AB vector, then this is going to be your resultant vector. So I wrote this equation in that way. Does that make sense? Okay. So, yeah, so from here, you can find AB vector now. So AB vector is equal to B vector minus A vector. Easy. Now I'm going to show you one important thing here. When you are dealing with position vectors, and then you need to find another vector, we call it derived vector. So this AB vector is not a position vector. Why? Because this is not an origin. Origin means the 0, 0, 0 point. So this vector is called derived vector, right? So if you are looking for a derived vector and you are writing that derived vector from a position vector, okay, that's what we did actually. So now you can see your first letter is going to be the last letter of this. Your second letter is going to be the first letter of this. There is a small catch. Knowing that, suppose you need to find AC. See, so you are not going to think about the vector addition or anything. It works there, but quickly you can say this is C minus A. So now in the very first day or the second day, I didn't show this to you. I just, normally did that. But we are mastering it down the road. That's why in VCE, 2 years is given to us. So now BC is C minus B. That's how you do the business. Okay? Good. Okay, so this is what I wanted to show you under this position vector rule, right? This side is cast, but this side is cast. Yeah. If you understand this guy, okay, I would say this is a node as well. Node number 1, right? So node number 1 and node number 2 and node number 3. This is another node. Node number 3. So if you understand these 3 nodes, that means you know vectors. This is the whole thing. Okay. Last note. O here, A here, B here. So A, B here. Now I'm going to say A comma B are position vectors. If A comma B position vectors, suppose you need to find AB. What is that? See, B minus A straight. Because AB are position vectors. Okay, Varsha, put it here. Good. Now I'm going to take a point here. I'm going to take a point here. I would say that point is C. Right? So then I can say AC vector, I can say AC vector is equal to lambda times AB vector, where lambda is a constant. Need for speed. You guys have played Need for Speed, right? Okay. Right. So AC is equal to lambda times AB, right? What do you know about lambda in this case? Lambda is less than 1 in this case. Now, I'm going to now listen to this fact. I taught you this fact. This fact is important in our next lesson as well, which I'm starting like maybe January, maybe February, right? That lesson is called vector lines and planes. So now you can see these are like stacking like properly, right? Think about this vector over here. These are given vectors, okay? These are given. And this one also given. Those are given vectors. I'm going to take this guy to be C vector. So this is C point, okay? C vector. This is not given. This is not given. Now, if C vector is not given, you have to find the C vector in terms of the known stuff, right? So what I'm going to do, using vector addition, right? So, oh, I have a question. Good. Listen to me. So now I'm going to say vector addition. So using vector addition, I'm going to say C vector is equal to A vector plus AC vector. You can see this guy plus this piece is equal to this piece. Now, A vector is fine plus AC is lambda AB. Now, AB is replaced A vector plus lambda B minus A. And that is C vector. Now you can see the way we construct this C vector, which is the unknown vector, right? You will see that this is lambda dependent. Why? Because of this. When you are changing lambda means you are changing the location. So you are changing the location when you are changing the lambda. So when you are doing that, your C vector also changing. You can see that. See? When you are changing lambda, you are jumping into a different location. Okay, Mila? Right? And then that vector is different. So it's a different C vector. That's why I said C is a vector lambda dependent. Now, right. So, let's say explanation. So this is my origin. This is my origin. So I'm going to have things like this. Right. So this is my C of lambda. This is my C of lambda vector. Now this point is going to be jump into this position. That means we are changing the lambda. So this is when lambda is equal to lambda. This is when lambda 1. This is when lambda is equal to lambda 2. So this vector is going to be now C vector. We call it lambda 1 vector. This is going to be C vector, but this is going to be lambda 2 vector. You feel that? So we are using the same vector notation, but when you change the inside, the values change. Example, you know fx is equal to x plus 1, right? So you understand f of 1 is different to f of 2 is different to f of 3. You know that. So likewise, the same name is used when you change the inside piece. When you change the inside piece, the location is changing, vector is changing. Right? Any questions? Now, don't just understand just what I'm saying, because you guys are VCE. This is not selective school. In selective school, you cram it. You do like 10,000 questions, you go, you pass. If you're a decent student. You can't do it here. That's why when you go to normal MHS, you can't find more than 10 to 50 sources. Cohort has 300. Not more than 20 students. Yeah. It's not because it is hard. Like for example, in my class, not last year. Last year I got 750s. How much is the group size? Half of this. This group is big actually. I got like 50s last year. Not last year, last year. 750s. So I'm not saying it is impossible. It is possible. Problem is students are not doing it properly. And then when the right knowledge is given, some people don't retain that. And especially from a person like me, obviously you get the right knowledge. Otherwise, what I'm doing to? I'm not a typical hanky-panky school teacher. So I definitely go to the depth. Whatever subject I teach, definitely go to the depth. So now tell me, when I show you this, so now that has a connection to this dude, right? So this dude, I explained to you over here, and then when lambda is changing, the message is when lambda is changing, this line is sort of deviating. But when it is deviating on this line, making the points collinear. You understand that? Collinear. The changing is making the points collinear. Now, these are different lambda values. Now, when you look at this picture, you have to come up with some thing. That thing is this. You understand, as I explained to you, fx is equal to x plus 1, f1, f2, f3. So those are different values, right? Different values. Suppose f1 is equal to 2, this is 3, this is 4, something like that, right? Now, if you want to plot it, you can plot it in a Cartesian. You can plot it. Those are Cartesian points, right? Right? You can plot it. So similarly, this one you can visualize. So that visualization is like that. It's different to this visualization. Okay. Now, in this case, inside piece here, we call it variable or parameter or whatever, is changing. When the inside thing is changing, so you put this to be x. And that we did here. See? Lambda. that lambda can be 1, 2, 3, 4, 5, 6 like that. It's very much similar to this we understood. So this concept is what you understood in grade 8 and 9, maybe 9. You are doing year 9, you did year 9 with me, 100% you did that. That is called function. This is a function, fx is equal to x plus 1 function. In grade 8 plus I did that. Now, we will try to differentiate that. That function is what type of a function? Children? That function is what type of a function? Scalar function. What you have learned so far in grade 9, 10, scalar functions. Fx is a scalar function, gx is a scalar function. Right? Because they are involved with scalar values. That's why you put the dots on the Cartesian plane. What is this dude? This dude is a function too, no? Why? Because see, lambda is changing. 1, 2, 3, 4. This function can be what? I gave you the answer to your tongue already. What is that? That function is called what? Huh? Huh? Vector function. I gave you the answer already to you. This is called scalar function. That is a vector, but you can see it is changing with lambda. That is called vector function. Now, vector function is a lesson in the future. You can see the connections. I'm not teaching like 1, 2, 3, 4. There are connections. If you build the connections right, you can do magic. So, we'll see. So, I'm going to give you this as now vector function. So, C of lambda is a vector function. Okay. Right. That's the whole syllabus, vector syllabus, in 15 minutes. Now, in the future, when we get some complicated questions, I will definitely throw you complicated questions, okay? Don't take me wrong, you must do it. My goal is to get 50, otherwise there's no point. So, there you will see some crazy things are happening. It's like this, but visualization. This way, that way, this way. Lambda and everything. So many things are involving. But like when you are doing those kind of questions, again, I will do a revision like this. Not in this level, maybe into a little deeper level. When you go to into a deeper level, so that I can show you how that concept is applied inside the question. That's the whole purpose. But if you have this knowledge, more than enough, okay? Take my word. But I'm going beyond. Not beyond the syllabus, depth-wise. Right. So far, so good. Okay. What I want you to do, this I will definitely look into it. So Monday, you all are coming on Monday, right? Eh? Eh? Speech night. Oh, this is a one-time thing. So whole nozzle is going to that? Yeah. Okay, it's not a speech night. Okay. Okay, anyway, so that's fine. Yeah, you can collect if you're coming on Monday, you can collect this on Monday. Otherwise, that's fine next week. I want you to redo this at home. I will upload that. I already uploaded that. Redo this at home. bring that document as a rectification. Yeah, that's your homework. Now, if I do this question one to one, this, I'm spoon feeding you. I'm giving you the answer. I don't want to do that. I want to give you the skill. Okay, that is one thing. So this lesson is done. Right.